Hi, colleagues. By means of introduction, my name is Monde Soni. My role is that I'm the chairman of the Load Research Chapter, which is under SAIEE. The session that we have today is one of the not so common ones. It's actually our first time that we had to get something of this sort off the ground. It's a positive byproduct of the situation that we find ourselves in currently. So we find ourselves in the shutdown situation because of the COVID-19. And there is something that came out of this that we need to look at our space, which is the load research space, the distribution, or even energy management space, wherever you are, wherever the interest is. And it only comes natural that, you know, when you are faced with these kind of things, with these unprecedented situations, you think about what your environment, how your environment will be affected. And that is how this discussion, you know, was initiated. And now going forward, we hope that as the Load Research Chapter, as you can see the website there on the screen, we hope that we will make these kind of reactions from time to time, and this will be or should be part of our product offerings. Going forward, we would like to respond to issues almost like in real time and engage the industry experts like you guys, bring you around the table and have your view. And at the end of the day, this will benefit someone who is an energy planner or an energy analyst, or someone who is running a distribution business. I would like to officially just open this by firstly stating, why did we find it important that we have a discussion of this sort that we have not had it that we have not had before? We find ourselves in this situation where we've got a lockdown, and this lockdown has its own implications in terms of, you know, the social impact, the economic impact, and the thinking is that there has to be an impact as well in terms of the way, you know, of the energy supply. Now, I will quote a couple of events that have happened in the past that have had an impact on the whole energy industry previously. So the first one was in 2008, 2009, when we had a recession. Now, when we had a recession, a lot changed, and a lot changed even in terms of how the consumers or the users of electricity, how they behave. Now, out of that, I remember the first NDP that I did, I think in 2009, sometime there, where we thought that the load was going to go back to the way it was in 2007 before the recession. But a couple of years later, we realized that actually this thing is not going back to what it was. And we still carried on, you know, taking what you call base loads, taking them from 2007 readings, even when we did studies, I think in 2009 and 2010, with the hope that things will just spring back to where they were before. And I think I see Rabba is here, Ted is here. You guys will probably remember those instances. Then that was 2008-9. Then in 2013, 2014, the mining sector experienced a very serious contraction, where it came after the Marikana massacre that happened in 2012. So the impact was the bigger impact was seen in 2013 and 14, And there also, we had a hope that things would quickly go back to where they were. And years later, that one incident just changed the way the mining industry consumes electricity, or we can say, no, I would say electricity, because if you look at the whole thing is energy, but there is a component of electricity in terms of the whole mix of energy. Then lastly, one thing that I wanted to quote is we had this monster that was called energy efficiency, and we there was a drive to put up all the CFLs, and these CFLs, I remember when we wrote a load forecasting standard some years ago, and we said, let's do a forecast, let's do analysis as though the CFLs are not in place. And the reason why we did that was we thought that these CFLs were going to disappear shortly. And when we checked in some areas, we realized that practically these CFLs are not going to last, especially in lower LSMs, because you would find that they were expensive, and ESCOM and the government went throughout the country replacing them for free. But when you have to replace it when it's broken, then this thing is so expensive. And at the spaza shop, people would find the old incandescent light bulbs. So we took that as an assumption that, hey, you know what, this thing, it's gonna go back to where it was. Even up to now, it still has not has not gone back to where it was. So quoting these three events, uh, we now realize that we are faced with this one. Obviously, something will have to give. Something, this is going to leave a mark that will be almost, I can say, everlasting. Now, the question is, what is it that this current situation that we are faced with, what is it that it is likely to leave us with? Now, that question has been forecast, and I was guided by the social media post that you see there and the responses to that, to focus this on distribution level. So when I say distribution level, I mean in our context, this starts from 132 kV all the way to the MV level, or even you can even include the LV if there is a certain aspect that you want to share with us at the LV level. So it's generally just looking at the localized little pockets and say, what are the localized constraints and what are the localized behaviors that we are likely to see coming through? And at the end of this should inform people who run the distribution business, be it municipalities, ESCOM, and other distributors that have their own spaces where they distribute. I posted what you see on the screen there. And the most interesting part is the responses that started coming through. The first one, I will go back to my post at the end, but the first one was from Enrich, as you can see. Then Enrich had a good contribution there, that he sees a load likely to behave in that manner, where he says that most people they generally start working at between 8 and 9. And basically, Enrich, what Enrich was saying is that there shouldn't be a problem on the distribution or localized networks if you look at the fact that people now will have a certain level of freedom to do things at different time, and that will bring in the needed diversity, which could overall bring down the load that's experienced locally at the distribution network. Enrich, I don't know if there's anything you'd like to add or on that.
Yeah, so I'll just give a quick explanation behind my reasoning there, and then also the follow-up comment that I later thought about. So, in terms of my first comment, that was focused towards the residential component of the load. So, in your post, you mentioned the fact that the diversity might change. And then I had a bit of a thought about this, and then I thought, so what usually the sharp morning peak or evening peaks during normal work days are associated with the fact that people have a very limited time span in which they have to concentrate all load activities such as showering and preparing food. So you have a very concentrated peak just before the workday commences, and then also a very concentrated peak right after the workday finishes, because people don't have the freedom to move the loading activities all across the day, maybe prepare food earlier or go to shower at 10 o'clock as opposed to 7 in the morning. So in terms of the instantaneous peak for the residential component of the load, I thought this lockdown might actually introduce more diversity because people can spread out the loading activities. So what that could potentially mean is that the instantaneous peak demand could be lessened, but the peak will probably be prolonged over a longer period. So as opposed to having a very sharp morning peak just before the workday commences, you might have a peak that's lower in amplitude but spread over a longer period. So a more sustained peak because people now have the freedom of waking up, let's say within a band of 2 to 3 hours of morning and then showering. And then later on, I thought about it a bit more. And then if you scroll down a bit, there was the second comment where I spoke to the commercial component of the load. So what I'm seeing now in current networks that I'm working with, where there's a good hybrid mix of a solid component of residential and commercial load, you have very high morning peaks at about 9 to 10 o'clock, where the last of the morning peak coincides with the onset of commercial activity. So the introduction or the shift of the commercial component of the load to within homes will now cause the introduction of an interesting hybrid profile of residential commercial. So usually residential networks, of course, were designed keeping residential loads and residential diversity in mind. But now the introduction of the commercial component complicates things a bit. So what I also said there is we are fortunate that this is not happening right in the midst of summer or winter, because then the network stresses will be severe. So specifically, if I'm thinking in terms of affluent neighborhoods. So the reason why I mentioned affluent neighborhoods, they are the type of people who can afford air conditioning in their homes and multiple heating sources, underfloor heating, that kind of thing. And a very significant component of the commercial load is due to space heating or space cooling, air conditioning or internal heating loads in multi-story buildings, which cause a very concentrated load in commercial buildings. So the thing about commercial buildings that actually I think causes or carries the most significant load is not the computers or the electronic equipment in the offices. It is, of course, the computer servers will draw a lot of power, but I think the space heating, air conditioning, and internal heating in the summer periods. So if you introduce that component into homes now, with people in affluent neighborhoods working from home and having the luxury to have indoor heating or cooling, that might introduce a significant commercial load component into residential distribution networks. But as I said, fortunately, this is not right in the midst of summer or winter, so that will alleviate some of that. But it will be interesting to see the hybrid combination of the residential and commercial load in these neighborhoods and see how the network responds to that.
Okay, interesting. Thanks, Enrich. I don't know if anyone would like to engage on Enrich's view before we move to the next one. Anyone who's got a question?
May I? It's Rabba
Yeah.
here.
How's it, Rabba?
I good, and you? I agree fully. I agree fully with Enrich, but I think in terms of the space heating, especially in affluent areas, I think over the years, at least over the past 4 years, especially people who can afford, they have adopted the idea of fuel substitution very well. So the people that really can afford, you'll find that they will do heating via gas instead of electricity. So that as well is an advantage, I think, to the grid. And I think the other point where I agree with them, the only stress to the network would be a prolonged peak, which will be reduced. but you find that in most, especially the municipalities, their networks, they operate about 120%, specifically transformers or substations. The transformers go up to 120% of rating because it's just an hour or so. But now that will change because it's not only going to be an hour. So we can take advantage of the of overloading transformers for a short space of time. So that's the challenge that I see. But overall, I fully agree with it. This is an advantage to shy away from the so-called dark curve to a more sustained, smooth profile.
Thanks, Rabah. Any other additional comment? Your question?
I think I partially agree with Anrich, but it is important to make a distinction between wealthy customers and their responses, perhaps, and the poorer customers and their responses. Anrich has quite rightly pointed out that people only have certain time slots to do things, but there's a marked difference between the choices that are available to poor customers versus wealthy customers. Poor customers typically have a morning slot and an evening slot to do everything, and they have no lunch peak. But if we go to the wealthy customers, they have far more choices available, and I would expect the changes to be smaller on the wealthy customer side. On the poorer customer side, I would expect to see a lunch peak appearing, and I would expect to see them starting to take advantage of the choices that they have. Whereas on the wealthy side, customers already have substantial choice, and the changes would be far less marked there. We can talk about coincidence and diversity on top of this, but let's give others a chance to talk.
Interesting. Right, so we'll move over now to the next comment that also came through, and I think this one here is very closely aligned with what Enrich's view, and I think Zoe also added. I see she's not here, so she also added that, for example, yeah, that one there. So, for example, she added that the normal office loads would be moved from the CBD into the suburbs, for example, but basically giving pretty much the same view as Enrich alluded earlier. Now, I don't know if there is anything or anyone that would like to comment on, well, in Zoe's absence.
Monday.
The next one. Yeah.
Hi, it's Hilton here.
Struggling.
Good, thanks. Yeah, just on Zoe's comment, I think one of the things I think Andrich alluded to it earlier, but I probably missed most of what he said. The moving of the office load, so the different constituent parts of office load, and maybe Marcus has got a bit more information on that, is what constitutes an office load predominantly. Let's say normally this time of the year. I think that's an interesting part, because if for example that constitutes, say, air conditioning mostly, then the question is, as workers are moving away from the office, what sort of impact does that have in terms of moving that load? For example, does all the households, for example, of those workers have air cons? I would guess not. It's just a very limited amount of people that actually have air conditioning at home, but they would have air conditioning at office. And obviously in affluent neighborhoods, that effect might be felt a little bit more, but as Marcus pointed out, we sort of have catered for that in any event in affluent neighborhoods in terms of their load profiles. So one should look at the constituent, different parts that make up the load as such, in an office environment or in a commercial environment, and shifting that away from the commercial environment or from the office environment into the household residential space. How does that then play off? And obviously then we need to make sure that our networks can handle that.
Okay, thanks, Hilton. So basically, what you're saying is office plus the normal domestic load. That's what that's
Yeah,
what you are predicting.
yeah. Well, what I'm saying though is that for the majority of areas, it won't
Yes,
actually be office plus domestic
plus
load.
domestic.
Would
Okay.
be it would be a spread out of the domestic load, as has been pointed out earlier. Plus, it would only
Yeah.
be a portion of the office load, because the majority of the office load is actually due to air conditioning, for example, during this time of the year, and that you won't necessarily see now at a residential house of
Okay.
most. That's the point I'm trying to make.
Okay. Thanks, Hilton. Any other comment?
Marcus here. Yeah, just keep in mind that domestic load is from the hands of people using appliances to create a household load, which then adds up to a local transformer load. So it's about whether people are at home, whether they have access to those appliances, and whether they do in fact turn them on and off.
Yeah.
So that sort of concurs with what Hilton has said. I'll hand over to Mike.
Yeah, Mike.
Yeah, thanks. Look, March, when we do energy modeling and we look at the climate files for, say, Johannesburg, March is a swing season. In other words, we're swinging from heating to cooling. What I've seen in some of the climate files for Joburg, for example, is we happen to have a heat wave. The sun is now lower on the horizon. In the middle of summer, the sun is directly overhead, beating down on the roof. As we move towards June, July, the sun at midday drops lower on the horizon, and you start getting solar heat gain through fenestration. So the funny thing is, in March, we've seen some of the hottest times of the year occurring in office blocks. Now, that's quite possible that we won't see that. My last comment is, we're probably going through one of the most incredible experiments ever, shutting down the entire world to see what happens to the load profile. So I'm hoping somehow that the Munichs, for example, have got a lot of data loggers out there looking at feeders and how feeders are behaving, given this particular load profile. Thank you.
Yeah, so that perhaps that's another point there, the one that you just mentioned in the end, Mike, that was raised by Lloyd in Lloyd's responses or in his post there. But perhaps before I get to that, yourself, Mike, you mentioned into this mix, you mentioned something that, again, I call this energy efficiency, where now you can achieve the same results cooking with really very little demand. And you quoted a pressure cooker there. So the question again that comes to mind here is, do we see this as a, perhaps, you know, I can put it like this and say, do we see this as a lasting impact and do we see this as something that is going to be, is it now going to be like this? Especially, for example, we can look at high-end LSMs, you know, those wealthy people that can afford those pressure cookers. And now, how do we see this affecting the way we know load models? Now, having asked that question, but then the thinking that I have is that, if I can give my own opinion on this, is with that, the main difference that you'll see is that if that cooking was to be done during the peak periods, then it will just reduce the peak, but the peak will still be there. And the only thing that it does is it will just reduce it. And now, again, it goes back and it messes up the load models that we know, that we've always known, that were derived at the beginning, you know, without these kind of appliances, because obviously the load models were derived with certain consumption of appliances and a certain number of appliances in a house, and a certain sorry, a certain behavior of people during the day, you know, the needs, the human needs during the day. I don't know if there is anything else, Mike, that you wanted to mention. Yeah.
Sure, Monde. So I think the thinking behind that is everybody's looking at the amount of energy used for different residential different residential loads, and one issue that comes out is, you might have heard of the slow cooking. So this is not perhaps about engineering. This is more about how people are treating things. So there's the slow cooking movement where people chuck stuff in a crock pot and they cook it over a period of time. And this can apply to right across the board, from people with lots of money to guys who are battling a bit. The focus then over in the US is on these induction cookers, and we now have a lot of solid state, silicon-based solid state electronics that switches far more efficiently, because the induction stove is driven by solid state power electronics. So at a higher frequency, you can transmit a lot more energy. We think that the induction hob or the induction cooker is going to become far more important. I bought the little hob that I've got for $600 from Hirsch's, for example, and we think that the price of these devices could drop right down. Now, what is interesting is that when you run these things on part load at maybe 200 watts or 500 watts, that is genuinely 200 watts. If you took your electric heating element in your stove, which is probably a 2 kilowatt element, and you try to run it on the lowest amount of heat, what would happen is it would switch 2 kilowatts on for, say, 5 seconds, and then switch it off for a period of time. So it's a sort of pulse width approach to controlling the energy. Having said that, you can realize that if your stove switched on exactly at the same time as the microwave and all the other things, you're getting quite a high peak load. So the game, I think, is to actually not only reduce energy used by buildings, total energy used, but also to reduce the peak. And you know, how do you do that? If you think of your geyser element as well, that's probably a 4 kilowatt element that switches on and off. If it were possible to have induction heating for your geyser, you could keep it on at, say, 200 watts for an hour instead of 4 kilowatts for 5 minutes. So I'm keen to understand what your guys' thinking is when it comes to the actual load profile of an individual device.
Yeah. So we had a presentation, I think during the course of last year, and it's probably also broadcast on our website, on our load research website, where the modeling was done at the appliance level, and it's called appliance-based load modeling. And it was exactly done for that purpose, to say, what if this changes and what if that changes? And there were some very interesting results that Yaku Alberts came up with, and I think his master's was also done on that. Some very interesting results that he came up with. I would invite anyone who is interested to check out on our website, look at the appliance-based modeling presentation under our media page. You will see. It's probably a tool that if you check with Yaku, you might actually he would be able to share with you. I don't think it's commercially available currently. But what we find to be a threat to the network is not necessarily energy per se. It's actually the power, which is the watts, the MVAs that have to be pushed at the same time. And if that diversity becomes is not there. So meaning that you've got high coincidence, that's when we start to have problems on the network. And that high coincidence can happen even if the energy that is being pushed through is, at the end of the day, you've got very low energy, but the instantaneous demand at some point during the day was very high, and that can compromise your network technical operation, or sorry, technical performance. That's the word. So I will just
Sorry,
quickly.
Monde, can I just butt in? Look, one of the reasons why I see a lot of my colleagues looking at this is clearly, were you to run your own microgrid, meaning you had PV and battery, and of course supplemented by the grid, and you wanted to island, remember, I don't think any of us would ever want to recommend that people go off grid. If anything, we're suggesting that they have systems that supplement the grid and remain good grid citizens. But the microgrid in particular, once you island, clearly you can't just start drawing massive amounts of energy for short periods of time. You have to balance out your load. And we're seeing a lot of the residential systems thinking, well, the people installing appliances thinking very carefully about how to avoid that coincidental load where you've got your geyser element and your electric kettle and your electric hob on at exactly the same time. And I think that's the challenge as well as people move over to energy storage and microgrids.
Yeah.
Monde?
Yeah.
Monde? Marcus, yeah? It's just whilst Mike was talking, I was thinking it's interesting what we're seeing with the kind of advanced technology like the stovetop cookers, the induction heating stoves and so on, is that they tend to be sort of self-scaling. They only use as much energy as required for that heat. They don't do this massive on-off element switch. There was at one stage, Mike, it might be interesting to you, as a hot water heater, geyser, that had a 2-element system in it with 2 thermostats, and the one was substantially less than the other. And that's basically the way that they use that device to reduce the demand. Thanks.
Yeah. Marcus, can you also just proceed and give your perspective as well? So I've gone through all the posts that were put online. Please put your perspective as well, and we can have a discussion on that quickly.
Okay, thanks, Monde. I think there's a bigger picture here, and then we've got the more local picture. I'll start at the local picture and then work upwards. Certainly what we've seen in terms of the behavior of people is that probably our best analog for how they're going to behave during a time of lockdown is something close to a Sunday. And if we say that people are going to behave somewhat like a Sunday, obviously they've got more degrees of freedom because they can move in and out of the house. It would be interesting to see if that comes through. But if it is like a Sunday, then what we would see is that the load factor would tend to increase marginally for poor customers, and the demand would reduce. In other words, the energy would be almost invariant. And that makes sense because people have a certain amount of end users and they try to get through them. That's in the poor side. If we go to the wealthy side, I would expect there to be a slight increase in load factor, but we would see the energy go up as well, simply because the wealthy customers are not constrained by how much electricity they can buy and use. They have the appliances to do it. If they're confined to home, they're simply going to do that. So that's the local effects. If we go to a higher level, obviously there's people washing around the country. and people have left the urban areas to go to rural areas and traditional homes. So that has happened. If we take a step even higher up, Mondi, you said 2008, 2012, I think, these big step changes that we saw. It seems that we're going to have an economic impact from the lockdown. The estimates at the moment are something like 200 billion rand loss to the GDP. That's kind of loss on our national production, and they're talking about 4% GDP loss, etc., etc. And if we turn that round to jobs, I would expect we're going to see substantial job losses. So there's going to be something like a net loss in wealth in the country. I don't know how long something like that would last, but the result of that is that we're going to see more people sitting at home during the day. I think the nature of our load profiles is going to change a bit. Thanks. That's all from my side, Mondi.
Okay. Thanks, Marcus. Now, the question that I have is, now if we split these two, we've got the wealthy, or let's say the high-end LSM and the low-end LSM, which I also agree fully with you that the behavior is definitely going to be different. Now, so is your view that this could lead to a more structured approach in one of the two? I think you mentioned something like that. So to mean, for example, you could have certain things in one LSM being done pretty much at the same time as opposed to another one, which perhaps has got more freedom. Can you just elaborate a bit more on that?
Yes, Mondi, definitely. If we look at the change in habits between wealthy and rich customers, between a weekday and a weekend, it's kind of a chalk and cheese thing. Poor customers, if they've got some degrees of freedom, they have a lunchtime hump, whereas they don't normally have a lunchtime hump. So they're clearly using the freedom that's been given to them. If we go to the wealthy customers and we compare what's going on a weekday versus a weekend, with the wealthy customers, we see that the lunchtime hump is actually reduced somewhat. So the swing is kind of almost opposite. But at the end of the day, they both have a marginally increased load factors. So yeah. So it is a mixture of effects. I really did appreciate what Andrich was talking about with the coincidence or diversity. There is something that we can see there, which is very interesting. With the poor customers, the coincidence is kind of largely unchanged. But when we get to the wealthy customers, I'd expect that the coincidence that we're going to see is marginally higher. So there is an increase in demand risk with the wealthy customers.
Okay, so then there is a point here that was submitted by Lloyd as well, mentioning that he sees a what I can call an LSM migration within the low end LSM, with many people moving from these economic hubs, moving back to mostly homelands where they come from, which is mostly those low end LSMs, the rural areas. And now when you have a load factor which is poor, so meaning that you've got a peaky load, and then you add volumes basically, because what will happen is that the family that, or the household that has so many members, will now see twice the number of those members that were there. Is locally now, looking at a transformer, looking at a feeder, is that something that we can, do we see any threat on that, or it's nothing to worry about? This is not for, it's the question, or this, I'm just opening it up as a discussion point for everyone. Any comments on that?
Yeah, this is Neto speaking.
Sorry?
It's possible that, can you hear me?
So, sorry, who is this?
You're speaking with Nat.
Oh, Neto, yes, Neto, yeah.
Yes. It's possible, but we must remember that most of the people do migrate during the December holidays. It might be different now since there's a lockdown, that they'll have to be homebound most of the time. So it's likely that it will have an impact on those networks only, but your urban networks might not be affected whatsoever.
Okay, so yeah, I see what you mean there. Yeah, I hear someone wants to say something.
Mondi, it's interesting that Lloyd said we'll get LSM migration. Now, he's quite right, but then there's also something very interesting. If you take a housebound, what we think right now is a housebound LSM 3 or 4, and you move them to a Sunday, then effectively they're starting to look like the load shape of a rather, more like a load shape of a wealthy customer. So Lloyd is kind of right in two ways. There will be LSMs moving to the countryside, but then there will also be the customers that we're going to have in these poorer areas. They will start to look like wealthy customers, but at a lower consumption level. Thanks.
Okay, thanks. I see that. And now, just on that subject, on that aspect of having a housebound customer, you've got a wealthy customer who is working from office, like the ones who have logged in here currently, and there are kids on the other side, and there is cooking that's happening on the other side. And I can assure you that my neighbor is probably doing the same thing, and the next one, etc., etc. Now, what I'm trying to put here is that we can, looking at it from perhaps from the surface, we would expect to see a great deal of diversity. But when you start to look at, for example, the human needs, that in the evening, we know that a human being is likely to want to eat, and for them to eat, then they need to cook. And now all that I see, that, you know, taking nothing away from all the views that have been put, but just pointing out another possibility is that we can easily see a shift, but not necessarily a decline, but just a shift. Instead of having things happening very early in the morning, but you just realize that everyone starts to do things from 9 o'clock. Now, there is something that, you know, for example, economy has to happen. You cannot start working from 1 o'clock. Now, if you look at certain areas, and again, using my own neighbors as an example, I know that from morning time, when we are supposed to be in the office, we are likely to be working. What did we do before we started working? Did we warm up water for coffee? Did we do it? So I think that becomes a personal preference. But at a certain time, there is going to be a time where between 8 and 9, we basically we need to do the same thing. We need to be working, and I think we need to work back from there and say, for you to start working in the morning, then what is it? What appliances are likely to be running? And I think we might actually be surprised, and we could have the diversity maybe in the morning, but in the evening, I especially in localized areas, it might be different from here to what is happening in a village, from Mabopan, etc. But locally, you tend to have people behaving in a very similar manner, and that is what could compromise the diversity that we had. And putting on top of that, putting the office load, which Marcus, you mentioned that it's the air conditioning takes about 80% of that. So if you take the remaining 20% and you bring it back here, you know, what level of diversity do we have? And something was mentioned by Raba here to say transformers, our network infrastructure can be loaded above its nominal rating, which is 100%. It can be loaded to 120, and I think some transformers you can push them to 150 even, but for only a certain duration of time. And now, I think if you look at it from that perspective, and you look at the fact that we are likely to have a flat curve, but with higher numbers, so meaning that you've got kids who are here for the whole day and they are doing what they want to do, and my neighbor's kids are there the whole day, etc. That will flatten the curve, and when it flattens the curve, it just puts the load for a longer period. And now the question that I have is, do we see that as a threat to our distribution networks or no? So I would like us now to give perhaps, let's say, some closing remarks and say, if you are responsible for operating a distribution network, is there anything to worry about if you are in a village and you have everyone who came back home during this lockdown and they don't know when they're going to go back to Gauteng? And if you are in a wealthy area and everyone is working from home pretty much, is there anything to worry about if you are doing operating of the network in that area, operating and maintenance? Can we just focus on that? Is there anything to worry about from the network services provider, the distribution network operator? I will give this to anyone. Let's go. First person. Anything to worry about?
I did some calculations here, and I see for about 600 units, I would expect the demand to come down about 10% for lower LSMs. Thanks.
At a national level, you're saying, or?
That's kind of at a transformer level.
Okay, you see, so
Okay.
Okay, thank you. Let me see, there is Andrach there, Andrach. Nothing to worry about? Yes, thing to worry about. I think you put forward two perspectives. You had your domestic aspect of it, and then you added the more commercial profile. So what would you suggest now to a distribution network operator who is here?
Monde, I like the last point that you mentioned. That is also something to think about. So usually with your morning and evening peak loads, they are cyclical loads. So the load comes, the transformer heats, and then the load curve flattens, and there's time for the heat to be dissipated. But now continuously running your transformer at a high level of load, I'm not quite sure. You guys should have more experience with industry experience with how that will impact the lifespan of the transformer. And also, in terms of the time duration that you can run the transformer at certain threshold levels. So that is something that you could see, which can definitely be a concern.
Yep. Okay. Thanks, Andrach. Basically, it's likely to age faster if you put it under strain for a long time. Then Hilton, I'm just going through the names in alphabetic order.
Yeah, I think it's been a very good, fruitful discussion, and thanks to everyone for the thoughts on this. I do think whilst there aren't immediate major sort of things that could jump out, there could very well be cases where distribution networks are already constrained. And then now we are adding additional load to those networks. So one could potentially see cases of quite a bit of nuisance tripping due to overloading that's happening on networks, transformers possibly, pole-top transformers, mini substations popping because they're being run at higher heats for longer periods. So I do think if I had to be the distribution utility, that I would be looking at my fleet that I've got, look at different scenarios that you could potentially have in your network and play around with a few studies to see if you're going to be okay through it or not.
Good points there. Okay, Marcus, you've already said something, and then it's me, Nedo. I think Nedo, did you? Yeah, but go for it, Nedo. What would you say, for example, for someone like yourself, who is operating a distribution network, with everything now that has been said, what would you give them as a takeaway?
Yeah, look, I'll comment on our side of sort of Cape Town. We wouldn't. I wouldn't have a concern that there would be any overloading on the low voltage transformer side, because the diversity is sufficiently enough. Because in some areas where we had made use of the HP algorithm, we find that the transformer is certainly idling. It's sitting at about 50 to 60% most of the time. So we won't have those problems in such sections. Then I'm in agreement with Hilton with regards to the fact that if a network was already problematic under normal circumstances, now you put it under a Sunday load, which is going to be continuous for a couple of weeks, obviously something is going to definitely go wrong there. And that's all from my end.
Okay, thanks, Nado. And I think you know what you've just mentioned now also makes a huge difference. What is the current state of the network? How is the loading currently? And you still have a huge room to maneuver. You know, be it the scenario takes a certain shape or it takes another shape. If you are loaded at 50%, you have a huge room to play around. You are quite safe, but I don't know. I know that some of our networks are loaded at just over 100. But Raba, you perhaps you anything from your side?
No, not necessarily for this platform, but I think, as I've mentioned in the comments, I think it also gives us something to think about in terms of how we do demand forecasting, as well as how do we do the energy landscape throughout the region, because this definitely changes the way we look at ADMD and everything else.
Yeah.
Thanks.
Yeah, no, definitely. And Ted?
Yeah, thanks, Monde. I think that the issue is actually much bigger than we thought. Today we spoke a lot around substation level, you know, your feeders and whatnot. But after this lockdown, in fact, after this virus, the trends nationally and globally will totally change. You know, I think we'll see less of the bigger shopping centers. We'll see more of working from home. We'll see a lot more mechanization in the mining industry. So there will be a big shift in the way energy is produced and consumed. And a conversation like this, there will be a need for a lot more of these.
Yeah. Yeah, and just taking basically from what you are saying there, Ted, I would definitely say that there is something to worry about when it comes to the distribution network, because obviously no one designed it with that kind of thinking. You know, if you look at your neighborhood now, just immediately changing to become an office environment, each house having an office, or being like an office, being run like an office, and there's homeschooling and all those kind of things that have to happen almost at the same time, then our networks would start to experience problems. But I think there is what is happening now, what is going to happen immediately as we transition. And then, as you have mentioned rightfully, there is what is going to be the long-term effect, that the long-term behavior is definitely going to change. Lastly, Tsolwane?
For me, really, what's interesting is how the residential load profile will change. If I'm just thinking now that instead of one working between say 8 and 5, I find myself working into the late hours of the night, whilst if I was in the office, it would have been slightly different. And I mean, I can imagine going into the future, more and more, like I'm saying on the comments, more and more people would be opting to do remote working. And yeah, I mean, definitely the load profile of residential, especially those who opt to work from home, will change going into the future.
Yeah. Okay. Thanks, Tolani. Colleagues, there is one thing perhaps, or one of many things that we did not touch on. Obviously now our time is up for this forum for today. Firstly, the fact that we mentioned businesses in the shopping centers are being closed. Obviously the demand from that side is going to reduce. Most of these shopping centers have got PVs on top, on their rooftops. And in most cases, if they are compliant with our NRS 097, then they would have, at least 25% of their notified maximum demands being the size of their PVs. Now, when they close half of the stores in main lane and only the grocery stores are left to operate during this period, then you definitely that 25% becomes now something else. Immediately it rises into a very high percentage. And I think even it's a topic perhaps for another day, but we are really likely to have those localized voltage rises in those kind of situations, unless the shopping center is so smart that they know they will switch off a certain array of PVs, which I doubt that would happen when they have certain stores that are still running. They might probably just leave them running there, and you will experience this imbalance now between the load and the supply, with the supply pretty much starting to exceed, worst case, starting to exceed the load at a local level. Now, from my side, in terms of concluding on this, I can say that at this point, we are all using our experiences. We are looking at what could happen. Nothing is guaranteed. Everything here is based on opinions and the previous experiences. And now, what I would suggest is this: if anyone perhaps was to do a plan now, a network plan or a load forecast, load analysis, whatever they are doing, consider all these opinions as possible scenarios. And then you can say, scenario one, if this happens, what will be the implications in terms of the technical performance of my network, in terms of the performance, SAIEE, if it matters anymore after this. And then you can reduce these into perhaps about 3 scenarios as a network planner and designer, and design a network that could be resilient perhaps for either of these eventualities happening. So there is no opinion that I would say it's wrong or it's right. We're all looking at what could happen. We'll wait for the data that will come out after let's say a few months from now, after the lockdown has been lifted and we have won against this coronavirus, then we will be able to look back and say, actually, we looked at these possibilities, and this is the one that seems to have actually happened during that time. And then we can come to what Ted was saying, to say, now, that was just a temporal shock. What happens in the long run? So, colleagues, with that, I think we can officially close the informal discussion. Thanks, Jens. We hope that we'll be able to respond to real issues that we see coming through as time goes, and expect to see a couple of these in future from us. Thank you so much. Bye.